And we're live. I'd like to thank everybody for joining this webinar. My name is Joseph. I've had the pleasure of working in aerospace, chemical reactors, heavy-duty diesel, medical, and now it's my pleasure to talk to you about Alibre. I'll share my screen and we can share our agenda. Uh, Today, we'll talk about why you're here, what Alibre is all about. We'll take a look at what it can do, and then we'll talk licensing tiers and options, and we'll actually have a few Q&A sessions because that's one of my favorites. I love to hear from all of you. First, we have our man Alex, who's our eye in the sky. He monitors the chat and keeps things running for us in the background. Alex, take it away.
He said I'll be moderating this, so if you have any questions, just throw them in the chat or the Q&A, and I'll make sure they get to Joseph and they get answered. So let's go ahead and go over the background of Alibre. Why are you here? Well, let's be honest. CAD feels harder than it should be. Costs keep climbing year after year, while the big CAD giants move the goalposts whenever they want. And when you need help, support often feels disconnected from the real-world challenges engineers face. What we want is speed, reliability, and control, not hurdles. That's where Alibre comes in. With Alibre, you get professional-grade tools that are powerful, yet intuitive, without the unnecessary bloat. You buy it once, you own it. Costs stay affordable, predictable, there's no surprises. When you need help, you'll be talking directly with engineers who understand your challenges. Updates come regularly, but they don't break your workflow. The result, lower long-term cost. In fact, our customers have already saved over $248 million in licensing fees due to our low-cost structure. That's money that stays with your business, fueling innovation and growth. Simpler workflows help you move faster, and faster adoption means new users become productive quickly. And through it all, you have real people, real support when you need it most. Now we're going to move on to the demo, back to Joseph for some awesome stuff to show you how great Alibre really is.
Well, thank you, Alex. Let me pull up a model here. This is one of my favorites. It is a cable car, and it really, I think, demonstrates the complexity that you can achieve when you work with Alibre. This is made up of many parts that are all put together. So you have all these separate part files that are put together to become one large assembly. And when we look at the kind of complexity that we can achieve, I think the question is, how do we start? So in this demonstration, we'll run through what the basics look like, and then we'll circle around to hit the really advanced and complex things that Alibre can handle as well. So I'm going to start by opening up my PDM software, and we're going to be talking PDM near the end of this presentation. But this is some software that allows our teams to be able to collaborate. If you're in a business and you have to collaborate between an assembly between a lot of people, this is the software to do it. And I have in here a door handle that I can get started with. Now, in Alibre, we have this graphics display window where we can see our green planes. We have to the left a design explorer, and this keeps track of everything in the graphics display window. It also creates a little recipe for our part as we move along. And then up top in the ribbon, we have all the tools needed to make a great design. Now, when we go to make parts in Alibre or in Parametric CAD, we can start with a two-dimensional sketch. I'll go ahead and create a sketch on my XY plane, and I'll make a simple rectangle. Now, CAD allows you to make things very dimensionally precise, and so I can add a dimension here, a very specific one. Let's go with 15.78 or 15.75 even, and then I'll give this a dimension of 3. So I've made a very dimensionally accurate rectangle, but it can still rotate. And sketches use things like constraints and relations to be able to constrain this kind of motion. So I'll grab a horizontal here and make sure that we are completely black, which means that Alibre knows exactly where everything belongs. I can use something known as the extrude tool that turns this 2D sketch into a 3D model. I'll give this a dimension of -0.5. And just like that, we have a, I guess you'd call it a rectangular prism and the very start of our own door handle. So I'll go ahead and show some of these other sketches that I've already made. I have a circle, a rectangle, and another circle, and I think we can make a great door handle out of this. I have a loft tool where I'll tell this circle to slowly transform into this rectangle. and then slowly transform back into this circle. Now, I think in my settings, I've turned off a 3D preview. So let's go ahead and fix that so you can see what I'm on about. Under Design Viewing, oh, I think 3D previews. There we go. I'll go ahead and grab this loft tool again, and now we should be able to see that. I turned that off just to play with something earlier. We can see how that circle slowly transforms into a rectangle and then back into a circle to get exactly the door handle that we need. Now, this looks pretty good, except there's a pretty sharp edge there that might hurt if I were to pull on that really hard. And we have this fillet tool that can help round out some of these sharp corners. So I can add a fillet here. We can see how this has really smoothed everything out, and we can continue to add interesting enhancements to our model. So this is what the modeling process looks like. We start out with a basic 2D sketch, and we can use a variety of tools to add different features and details that create a very good looking model, and we can build in our design intent for CNC, injection molding, or however you wish to make your parts. Now that we've added a bunch of features and we have something that looks like a door model, we can come over here to our Design Explorer, and we can see all the things that we've done. We've added a chamfer, a fillet, a loft, but we also can roll back and see one step at a time all of the features that we've been able to add. Now, this is what we would call parametric because we can go back to any of these things in our history, and I can say, you know what? I have a new constraint. I need to make this 16 instead of 15.75. And all of our dimensions update, and we can see the new model instantly with the changes that we've been able to make. So we're able to not just make a part, but dimensionally accurately adjust for everything that we need to. So this is a good example of a part and how we can go back and forward in time with this recipe that we would call a design explorer or a history tree. However, what does it look like when we put a bunch of parts together in an assembly? I'll grab a small engine here. And once this comes up, I can say, you know, I want my engine to actually work and move like a real engine, of course. And so in assemblies, once we put parts inside, we can grab our constraints and we can say, you know, I want this wrist pin to be right around my connecting rod. And simply by clicking, Alibre can ascertain what kind of relationship we would like to have. I'd like my crankshaft to be butted up right against this part of the cylinder block, and then I'd like my connecting rod to go right on my crankshaft. Now I've put some transparency right on our cylinder block, and as I move this, you can see a very realistic motion between all of the parts. And this kind of visual confirmation makes it very easy to see that things clear properly and don't interfere. One of the easiest ways to check for errors very early on. And the sooner we can catch errors, the more that we save. So why don't I run over to a more complicated assembly now? One of my favorite models, we have this beautifully made steam engine. This is made by one of our users named Harold. And I love the realistic visualization of these kinds of motions. As I spin this, we can see that this is moving just as we would expect. Now, there are some things that we might want to check. So I can certainly spin the shaft and see that all these things are interacting. But if I look at a joint like this, I might ask myself, well, what if my hole is too small and my pin is too big and there's an interference? But there are a lot of quick and easy tools that we can check. For instance, I can say, you know, I want to check this pin against all of these other parts and make sure that nothing is interfering. And when I check, I can easily have the peace of mind that no interferences are found. Now, this is a wonderful tool, and I'd like to actually pull up another example of using this. I have a injection molded stool here in my PDM. Go ahead and open that up. This is a stool that has the early stage tooling, a core and a cavity, and I want to make sure that things fit together well. I'll suppress some of my mates here and pull out my core. We can see a rather complex stool with a lot of support ribs and patterns in there, and things look like they go together well. But how do we know that everything is fitting together well without cavities and without interferences? Well, I can go with our inspect and once again run a global check against all parts. And after a quick second, we can see that there is no interferences found. I also can view section views very easily in Alibre, and I can see my stool sitting right in the middle of my tooling, and I can see that there are no cavities. So things fit together as we expect, and we can easily check some of these things. Again, this is critical to avoiding costly mistakes, and that's where these tools make all the difference. Once again, I can return to my assembly here with my steam engine, and I've got a lubricator that is lubricating this shaft inside of my engine. And I have to make some minor updates. It turns out that where I put the lubricator is a little bit off. So I'll relocate this lubricator. Again, we'll, instead of say 2 inches away from that face, we'll make it something like 10. And as this shifts, we see a problem. Our lubricator tubing is no longer going through that clamp, and it's not meeting where it should anymore. Now, minor assembly changes can turn into a frustrating chain reaction of manual edits, resizing parts, replacing holes, double checking alignments one by one. It eats up valuable time and it increases the chances of errors slipping in. But we have a secret weapon. Now, with design in context, I've actually been able to define this tubing in the context of the assembly. So all I have to do is make sure that everything is regenerated and it automatically snaps to the right place. We'll do that one more time because if you blink, you might miss it. We'll move our lubricator and see that it is just not lining up, but by clicking regenerate, the tubing snaps to the right place. So when we need to make these parts, we can avoid the frustrating cascade of adjustments and we can go ahead and work on what matters the most, improving our design instead of fixing it. Now, here's a sleeve bearing, but I wanted to update this, and I added a little hole right here for a ball bearing to go in. So let's insert a design from our PDM. Here I have my ball bearing. And as I go to put this in, I can see that it is immediately the wrong size. Now, anyone working in CAD knows that we have to resize and adjust things all the time, but manually editing dimensions, recalculating clearances, or adding or removing elements like the number of rolling elements in here can be a real pain. It's slow, prone to mistakes, and we can have another secret weapon that saves us from all of this. I'll go ahead and edit this bearing right here in the assembly, and I have an equation editor. So I'll go ahead and open that up. And this has been designed with equations in mind. So I can say, I want the ID of this bearing to be 6 to fit around that shaft, 8 to fit within that other element, and then I'll make it a little bit wider at 1.25. Now, when I go to update this, we can see that it is instantly updated and with the correct number of rolling elements, taking all that out of our hands. And we can simply go forward with equation-driven intelligence. Now I'm going to edit my main assembly. And we can simply put this exactly where we'd like to have it. So I'll add a constraint and make sure that this face is aligned with this one. And then I'll place it right here in the housing where it goes. Now we have some other spots in our assembly where we need a bearing. In fact, I think I didn't put that in at quite the right orientation, so we'll go ahead and go to our constraints. And it's as easy as flipping this around. Now, once I put this bearing in on the other side, we'll be good to go, but that can be kind of cumbersome to insert parts one by one. And that's why Alibre has linear and circular patterns available. So what I can do is run a mirror here. And I can say that this plane runs right through the middle of my assembly, and I'll mirror that bearing. And just like that, we have a mirrored bearing. What's very great about Alibre is, let's say I have a left shoe and my assembly requires a right shoe. Well, I have the option to create an other-handed copy if I need to mirror an entire part on the fly, which saves me from being able to trace individual parts and create new files for mirroring. We can handle all of that complexity right in the assembly. Now, if I shift our focus to this upper flange. This is a blind flange covering our engine, right? Maybe we need to ship or maintain the engine with something that keeps it clean. And we have a bunch of holes that need to stay aligned. And that can be a real pain in the sense that maintaining consistency across multiple files can mean chasing down dimensions in multiple parts, updating them one by one, hoping nothing gets missed. Instead of doing something that's tedious, error-prone, and a big time sink, we have yet another secret weapon up our sleeve. Now, if you're thinking the design and context that we did with that tubing would work, I think it sure would, but we have something even better known as global variables. So I'll chase down my steam engine, and I have a global parameters file right here. Now, this has a lot of the dimensions built right into our file. This looks a lot like those equations that we were doing with that bearing, but this applies to many parts. So let's say I want to update my blind flange and engine with a new bolt circle diameter. Maybe we'll give that 12.5. We'll give the holes a larger diameter of 1. We'll reduce the number of holes down to 8. Maybe we'll make a bigger diameter at 15.25. And we'll make everything thicker at 1.25. Now, making all of those changes by chasing down each part and changing those in the history tree will take a long time. But here, I just need to type them in as I've done and click on Update Designs. Now we'll watch as this updates instantly right there. And we can see that our holes are all lined up and we've been able to drive the entire assembly. Now that's a simple example, but imagine if you have an entire shelving assembly, you can update the entire assembly with just these parameters. So if you're making custom shelves or anything like that, your updates become instant instead of chasing down files. Now, I'd like to point out that I don't actually have any bolts on this coupling. One of my favorite sites for parts like that is McMaster Car, but the novelty of going there every time I need a bolt or a nut or a washer, downloading it, importing it, it wears off pretty quickly. And again, our goal is to maximize your time where you want to spend it the most. And that's why we have a Libre toolbox right here. This allows us to have complete control and even make configurable libraries of our own custom parts. Right now we have a samples folder, but in future versions of Alibre, this will be filled with fasteners, tubing, angle iron, all kinds of off-the-shelf parts when you need it. So stay tuned because this is going to get very full pretty quick. Here, I've made my own custom bolt, and you can make your own custom parts configurable in this as well. If you're in the phone case business, you can insert a configurable phone case right on the fly. Here's what my bolt looks like. Now I know that this hole needs to be for a bolt just under 2 inches, and I've created a little designation where I can choose, again, a bolt that's just under 2 inches. Now the preview will update and we have a larger bolt, but of course I need it to have a longer shaft length. We'll give that 10, and it'll give this a thread length of 3. Now once that bolt comes into the assembly, I can go ahead and save this as a part. In fact, I'll just throw it right here on the desktop. And once again, I'll be able to place this just like I would any other part in the assembly. So we can have entire libraries right at our fingertips, and we don't need to go to external sites or import parts, and we can do this with all of our custom parts, so it will be sure to meet your needs. Now again, I can create these bolts or duplicate them one by one and insert them, but with our patterns, we have the ability to do so much more quickly and easily. I'll create some more bolts right on the fly, and I can see that in my number of instances, I've got the right number of bolts right there. Now, I love having pretty pictures, and so I am one to throw highly detailed threaded bolts right in our model. But of course, these take up some processing power, and I think most people would rather have a stand-in for a bolt that isn't so detailed so that their computers can run fast. When we need to have versions of parts or families of parts, there's a great thing known as configurations that allow us to have the power to do that. I think one great example is this hummingbird feeder. This hummingbird feeder has a lot of configurations around it. This is an assembly, so configurations are not just for parts, but assemblies as well. Here is a hummingbird feeder where I can activate a new look, and all of a sudden I'm feeling quite patriotic. It allows our assemblies to have different parts or appearances. And so instead of having to trace down all of your different versions of a part, we can have it all in a single file. This allows us to save time and reduce errors. Without these, we'd be stuck manually copying, editing, and tracking many files. But for faster, cleaner workflow, configurations rather are a big help. I'll pull up one other example because sometimes it's important to have a family of parts. Here's a 6mm wrench. And of course, I may need to turn a bolt that's 10 millimeters. In fact, I recommend having two because anybody who's worked on anything knows you always lose your 10 millimeter. But just like that, we can activate our different configurations and see the entire family of wrenches and all their sizes all in one. So configurations will speed up your workflow and simplify all of your files. Finally, you may have some salesmen or people who are working with your products and customers that are not used to CAD or have never used it before. Let's talk about one handy thing for them. I'll open up a new part in Alibre, and we have a library tab right here. And in our library, I'll click on Generate. So we can have a catalog of parts that can be generated with a unique and easy interface. Maybe you're in the alloy wheel business. I've got a Supra in the garage that I sure would like to have some more wheel options that fit it. And so naturally, I made an alloy wheel that would be capable of fitting my car. Here's a 4-spoke, 4-lug wheel. And let's say your salesman is sitting down with your customer and they want, of course, a 5-lug, which is much more common. Well, your sales guy just needs to change the lug count to 5 from this drop-down menu. Again, this is a completely custom part. And we'll see some intelligent updates. The spokes will become slightly narrower to account for the extra spoke. Our bolt circle pattern will change slightly as this very complex part loads. And we even have some diameter updates all happening in the background with the intelligence that we build in. Now, perhaps your customer wants a larger 18-inch wheel. Well, that is totally achievable, again, just by using the options in the drop-down menu. So we can have entire features that show up or go away based on the values that we put in this thing, and we can see some amazing updates. Now, my Supra is a 0 offset, which is a little less common, and so naturally, I'll put a 0 in there and feel the joy of knowing that at least this model would fit my car pretty well. Just like that, we see the offset update in real time with all of these complex features working together. So again, we can simplify everyone's workflow a lot, even for those who do not use 3D CAD. Now, I might want to point out that the things that are holding my studs in my house together right now is sheet metal. In fact, it's in our phones. It's just about everywhere. We're probably rarely an arm's length away or more from sheet metal. So when it comes to sheet metal, you may need to design something in sheet metal as well. And that's where I have this lifting jack. I'll pull up the assembly here, and we can see that it's made out of sheet metal. And as I twist it, it goes down or up just as we would expect a real jack to do with our assembly relationships. I'll open up this base here in a separate window, or I can edit it. Now, the trick with sheet metal is it will stretch or compress when you bend it, and so you need to calculate what those dimensional changes are going to be in every bend so you know just how to make the flat pattern. But the magic of Alibre is it does all of that on the fly, so you can make your final part in its finished dimensions, and Alibre figures out what those flat patterns should be. When we go to add a flange, we can specify a K-factor under bend allowance or even use unfold length options to be able to figure all of that out. So being able to have a correct sheet metal part very easily is very important. But I think all of us are going to work with suppliers at some point. And here I have a project for a gearbox drawing. Now, it may be hard to find in all of these files, but our search feature makes it pretty easy to pull up. So as I load this gearbox drawing, we do want to have unambiguous drawings that we present to suppliers. And that includes all the options for drawings. We have broken out section views, detail views, we have aligned section views, and so on. So as this drawing comes up, we can see that there's a number of views already here, and we have a number of callouts that tell us what these parts are to make it clear. Now, if I change sheets here and go to our parts list, we can see a pretty complex exploded view when this changes, as well as an updating bill of materials. A picture is worth 1,000 words, and these exploded views of our assemblies really tell us how things should be assembled. Now, these bills of materials are updating, so if I change something in my assembly, our quantities, our part numbers, our descriptions all automatically update with properties. The same with the values in our title block, so we don't have to worry about chasing down values or updating things manually. This is a completely custom title block that the customer has made, and so we don't have to worry that we are forced to present information in a certain way. Instead, we can make our own standard title blocks to our own specifications with updating properties. Now, we have assemblies covered, but what about being able to dimension parts? I'll open up a bracket, and I've got a drawing of this complete GDT bracket. It has a number of feature control frames. We can even do compound frames or composite frames. We have, between 2 points, we can have a profile of a surface, unequal tolerance dispositions. We should be able to have every dimension you need to get your tolerances exactly how you want them. Again, that's very important because we want to get the right and the best information to our suppliers. So being able to portray our product in a drawing is not much of an issue. But what about being able to portray things with, say, our stakeholders, our boards, or even customers? Well, we want to have a really nice picture for our customers. Now, here's a tort bowl, and it looks pretty nice. We have features that go all down the surface, but how might we want to present this to people who really need a pretty picture, like in marketing? For that, we have something known as KeyShot. This comes with certain versions of Alibre, and when I pull up KeyShot, we can see that it will open up this KeyShot render program and automatically import our design data. Nothing else needed. Now, KeyShot has the ability to portray our part in a number of different materials rather. I'll jump over here to glass, right? And I love being able to see the way the light plays off of this almost instantly. I can check different options, but I think my all-time favorite is this wavy glass that really captures the way that light might travel through something like this tort bowl. And just in the space of me saying a few sentences, I am now actively rendering a tort bowl in a photorealistic fashion that should look great for any customers, board members, or other stakeholders that have an interest in our products. Now, as we talked about before, we've seen a really complex cable car in the beginning, and when we're dealing with very complicated assemblies, we might care about how our data is used, and that's why we have this PDM browser. The PDM allows us to have projects and libraries full of parts. It can back up and restore parts on a regular schedule and keeps versions and version histories of our part. So when I go to open up my Steam engine, I can see past versions. I can see what state they're in, right? I can say, oh, I added the lubricator tube in this version. And I also am able to see all of its constituent parts in a list. Here's my assembly with all of my subassemblies and all of the parts that make up those subassemblies. And I can even pull up exactly where they are at a given time. This helps me greatly with traceability. I also have a lot of metadata and version control when I work with my assemblies. Here, under properties, I can see different versions and things to fill out, like when it was created, who the suppliers are, and so on. So these PDM browsers really help us to stay in the loop. Finally, I'll throw in one more thing. I believe professional and expert versions also have this script um, menu where I can create custom scripts or use some that come with the Libre. For instance, involute spur gears are so hard to make models of, and yet with scripting, I can simply start to create a script. I'll make a very odd gear. Let's give it 27 teeth with the diametral pitch of 23.7, and I'll make it 10 millimeters thick. And when I click OK, I instantly have the gear that I need. And so scripting is another way that we can take complex things and make them easy. Now, I think there might be a few questions. Let me jump into the Q&A part. One of my favorite parts is being able to talk to all of you. Anybody have any questions about what a Libre might cover, how to do something, or anything? And I think we might be dry. You know what? There's another QA coming up, so let's simmer on anything we talked about today, and I'd love to hear any questions. And we also have our sales aficionado on the line with us. We have Matt Feldman. Take it away, Matt. And I think you're muted there. Yep.
Oh, all right. Hi guys, I'm Matt, and I'm an account and sales manager here with the Libre. I'm a professional with a strong background in customer engagement, sales, and technology, with years of experience helping designers, engineers, and makers all find the right CAD solutions. I'll be walking you through what a Libre design is all about. That being said, let's get started here. All right. So whether you're brand new to CAD, coming from another platform, or just curious about what we offer, this session is going to give you a clear picture of how a Libre might fit your needs. And no matter which license you choose, you'll have the option of a lifetime or a subscription plan. And we offer perpetual or lifetime licenses where you'll own the software. There's no subscription required, and that's what majority of our customers have. It's our bread and butter. All of your files are going to be locally stored, and you can use it as is without having to update it every year if you choose, or you can just go with the subscription plan. Either way, Libre is not going to lock you in with the subscription for the lifetime license and hold those files hostage. Also, the lifetime license does offer the best value over time. Subscriptions are the second option. So if you prefer using it temporarily or a pay-as-you-go type of project, then that's the way to go. We do offer optional maintenance plans for the lifetime license. It's going to protect you when you have a deadline and you have any needs for urgent assistance. You know, Libre is here for you with priority design support. We do believe in offering flexibility so you can decide on if you want the updates and support or not, or just continue with the subscription plan on a monthly or yearly basis. We do highly recommend the maintenance because it's going to give you all the features and updates as they're released. You get priority technical support, and you get access to the online license portal where you can remotely transfer your license keys as needed. The lifetime licenses do come with unlimited installs, so you can put it on as many machines as you like and transfer the key back and forth. Maintenance is inexpensive, and it keeps your software current. but you're never going to be forced into it. So if you skip a year or two, you don't have to worry. Your license is still going to work. For the lifetime or perpetual licenses, we do want you to be successful. And that means as you improve your CAD skills, you may need or want to upgrade to a higher level license for more functionality. And we do provide paths to do so. You'll get credit for your current license purchase towards the upgrade. You can start with the lower level license and then grow into the higher levels as you're ready or as your skills carry forward. Alibre offers 3 license types: Atom 3D, Alibre Design Professional, Alibre Design Expert. In that order, they're each designed for different types of users, and you could think of them as like a good, better, best. They all share the same clean parametric core, but each step gives you more power, efficiency, and flexibility. So to start with, Alibre Atom 3D. That's going to be for makers and 3D printing. It's an excellent entry point license, whether you're designing gadgets, 3D printing parts, or doing home-based CNC projects. You get all the essential modeling tools, physical threads, and more. You can export to industry standard formats, and you have basic 2D drawing views. Again, this best fit is going to be for hobbyists, beginners, makers, inventors, and a focus has been placed on making the interface as simple as possible while still providing ample power. Our middle tier is the Alibre Design Professional license. That's going to be for hobbyists, beginners, makers, inventors, with a focus on makers moving from single parts into a complete product design. And you'll step up to pro if you're needing a more professional level tool set, but still affordable and able to provide ease of use for small projects. Professional is going to be the baseline tool set needed for professional product design. It includes everything in Atom 3D and offers tools needed to indicate the design intent to a third party as well. So you're going to have tools to save time, provide efficient workflows. You can create bill of materials, section views, exploded views. It also has the Python-based scripting, and expanded import-export functionality. It's going to be a rock-solid daily driver for small shops, serious hobbyists, or anyone who needs assemblies and documentation, but does not need the advanced specialty tools. And then the third one is the Alibre Design Expert. That's going to be a best fit for professional designers, teams, and anyone needing advanced fabrication like sheet metal, marketing visuals, motion, or product variants. It's our fully loaded and most powerful license, and also our most popular license. You get everything in Pro, plus advanced tools and professional workflows. The PDM integration, Joseph touched on that for managed data and team environments. You can see updates in real time. Get the sheet metal module, design configurations, photorealistic rendering with the key shot, and the dynamic part library to name some of the highlights there. And so whether you're designing a hobbyist for parts on the weekend, or a small business making assemblies for production, or a professional shop that needs advanced sheet metal and rendering, there's an Alibre license that fits your needs. Best part, you own it, your files are all locally stored, and it'll grow with you. We are offering a 30% discount through the end of September, only for the guests of our webinar here. And you can feel free to reach out to me or any of the sales guys. You can reach us at hello@alibre.com, or you can give us a call and we'll be happy to help. Thank you. With that, I'll turn it over to Joseph, and we'll be able to take any last minute questions.
Hey, thanks so much, Matt. Yep, this is the Q&A for any licensing or upgrading or any questions like that, if anybody has any. I did see a comment that I really like. It said from Martin, great capability overview. Need some more videos on things like applying constraints and other detailed concepts. And I'm so grateful for that comment, because it is really hard to put together a webinar and also cover the small things. I'm going to stick a comment in the chat of our playlist, and I'll share my screen here so we can see it. This is a playlist that is intended to be a completely comprehensive view for anything that a starter would need. We have, I think, over 70 videos in this. And I think number 7 is actually sketch constraints, relations, and definitions. And so if you go through this, it should be a completely full view of everything in Alibre. We have a number of standalone videos as well, if that is helpful. And we have a forum and a help desk. So if we're trying to get started, these could be some great places to start. And hopefully that's helpful in having some more content on constraints and detailed concepts. Oh, and I got to thank you for Martin, and thank you for asking that question. I think I see another one here. Does Alibre offer standalone application development for a company that has designed its parts with Alibre, an app that allows customers to configure them or something of that sort? That's a great question. I know for certain that we have some developers that have created some add-ons for Alibre for application development. Max is on the line. He might have some more details for us on that one.
Yeah, I'm just reading the question real quick.
Sure thing.
So does Libre offer standalone application development for a company that has designed its parts with Libre, an app that allows the customer to configure them or something of that sort? So something like that could be created. Libre doesn't create purpose-built applications for our customers, but we do have a framework that allows extensions. So if you have a developer, they can utilize our API to create a custom-built application for your use case that takes advantage of the Libre engine and can be used quite extensively in terms of automation and customization for your workflow. I'm not positive that exactly answers your question, but I think it might.
Fantastic. And does anybody have any other questions? I think I just saw a hand go up.
Hi.
Hey, this is Frank. How's it going?
Yeah, I'm good. How are you doing?
Great, thanks.
Good. So I've been using Libra for quite a few years, and I have a question that might be a little bit too detailed for this, but it has to do with assembly constraints versus designing parts in the assembly environment using inter-design relations and things like that. Um, kind of what's considered best practice with Libre, and when to use constraints, and when the inter-design relations would make more sense in terms of like robustness of the assembly, and it less likely for it to blow up on you and stuff like that. Um,
That's a great question. For me, and you might get a different opinion depending on who you ask, but
right,
I would always default towards using assembly constraints first and
right,
design in context as a secondary measure. And I would say design in context really shines when you need to make updates and don't want to do those small fixes like the tubing in there.
right,
But I would probably avoid it if there's any possibility that a constraint would do the job, in the sense that if I were to move that pump in a very, very unexpected way and change the orientation dramatically, it still would break that sketch. And if there's a constraint that can do it, then it would make a lot more cleanly. So does that answer your question?
yeah. Um, if you're ever stuck for video ideas, that might be a good one.
That's great. I will make a YouTube video about it then.
Awesome.
So
That'd be cool. That'd be so
keep an
cool.
eye,
Thank you.
you bet. Keep an eye on our channel, like and subscribe.
I will always.
Thank you. I really appreciate the question.
Thanks.
Seeing any more right now. If anyone has any last minute questions, whether it's about application or sales or anything, please feel free to drop them either in the chat or Q&A, or you could do like Frank just did and raise your hand. We'd be happy to call on you.
Well, I think we're pretty full here. We're at 59 minutes and 11 seconds. I think we hit the time perfect.
Yep.
Well, we'd like to thank everyone again for your time. Again, we're 30% off till through the end of September, and we really appreciate it.
Thank you, guys.
Thanks, guys.
Thanks.